If you're a JavaScript developer, chances are you didn't learn about value versus reference. You may not even know what I'm talking about when I say that. It's one of those things that rarely gets the attention it deserves, but it's a fundamental feature of JavaScript and the source of a ton of bugs for all of us. And if you knew how it worked, you could save yourself a ton of time and pain. So what is this all about when we say copy by value versus copy by reference? Why should you care, and how does this affect you as a JavaScript developer, whether in your day-to-day job or in interview process? By the end of this video, you will master this fundamental concept. Welcome back, everybody. This is the last episode 10 of this 10-part series I'm calling 10 Things JavaScript Developers Should Know, but probably don't. Final episode 10, value versus reference, plus a big announcement at the end of the video as to what we're gonna do after the series. And spoiler alert, it involves you. There are changes coming to color code and I can't wait to share them with you. With that, episode 10, let's do it. In episode 1 and 2 of this series, we talked a lot about inheritance and how in JavaScript, prototypes are the way we create inheritance hierarchies. I also showed you that everything eventually is an instance of the object type. The truth is, however, that there are two types of values, not just objects: primitives and objects. But wait, real quick, what are values again? In a variable declaration like this, you have the variable on the left side and you have the value on the right side. So if you take all kinds of values in JavaScript, you have two kinds. You have primitives, these, which are number, boolean, string, null, and undefined. And you have objects, these ones: object, array, function, date, regex, and a couple other ones. But why do we care that they're different? Well, we care because they act differently in important ways. Most importantly, in the way they are stored. Okay, so what does that mean? Let's start with a simple example. To the browser. All right, let's start with the simple one. Const A equals 1. Const B also equals, actually, let's do 2. A triple equals B. False, of course. Makes sense. Let's do another one where A and B are the same. And I do A triple equals B, true. Simple stuff. Not a big deal. Now, what if I do A equals an array that houses 1, and same thing with B. A triple equals B, false. Huh? Now, it is the easiest thing in the world to look at this code and say, wow, JavaScript sucks. That is a lazy way of looking at it. Don't become one of those people. This is a cop-out answer. Don't cop out. Instead, we can try and understand what is going on here. I grant you that there are parts of JavaScript that were decided on and implemented decades ago, and they are truly weird and don't make much sense. This isn't one of those scenarios. So to explain this, one thing you'll notice is that one of these is a primitive. So this one is a primitive where the two are equal, and this one, they're not primitives. They're objects which are, arrays which are a type of object. So it doesn't matter that there is a primitive inside it. What matters is that it's an array. So let's try one more thing, another primitive value, let's say a string. So refresh const my name equals Sina. Okay, so before we go any further, we need to understand what this one line does. And I promise you, most of you watching don't fully understand this one simple line of JavaScript. And some of you most definitely don't know the difference between this line and this line. My, say, car equals an object, right? Those are two kind of similar looking statements, but they're very, very different. And I'm gonna dissect them. I'm gonna need my trusty animation though. I don't think I can code this. So I'm gonna get out of this bubble. Whoops. I'm gonna use my trusty animation board. When you assign a value to a variable like this, JavaScript does one of two things, depending on the value that's on the right side, this being the value. If it's a primitive, say a string, JavaScript takes the actual value of the string and points the variable to that. It doesn't create a new string. And that is key here. On the other hand, if it's not a primitive, let's say it's an object, JavaScript actually creates the object from scratch and points the variable to the location, not the object itself, but the location of the object in your computer's memory, aka the address, aka its reference. But wait a minute, that's not what happens with strings. If we don't create a string, then where does this come from? Well, good question, Craig. You can think of primitives as values that already exist in memory. It's a totally different way of thinking about it, and I know it's a little more complicated than that, because obviously JavaScript can't have all the possible numbers and strings in the world in its memory. But for the purpose of the value assignment, primitives are what they are. The value itself, it's that simple. What you see is what you get. So let's go back to the browser real quick. I'm gonna try one more thing. Const A equals 1. Okay, and const B equals 1, same exact thing. A and B literally have the same value of 1. They don't have a copy of 1. That's the important part here. Whereas if I have I can create objects now. If I have two empty objects, A and B have totally different values, even though they look alike. One is always 1, but an empty object isn't necessarily the same thing as another empty object. They're like twins, identical, but separate people. Now back to the original example, right? When we do the triple equals, 1 is always 1. JavaScript looks at that and says, true, they are the same thing. Whereas if I use a non-primitive, so let's say I use an array, that was the example we had before, A triple equals B is going to be false. So now hopefully you know what is going on here. An array with the number 1 inside of it is not the same thing as another array with the number 1 in it. Think about it. Maybe the first array is my favorite single digit number. And maybe the second one is the number of times I have fallen down the stairs this week, also 1. So they're representing two very different facts, whereas 1, again, is always 1. Or let's use an object this time. Const A equals skills, or skill. Let's say we're representing two different people. Skill cooking, right? That's person A. Person B might also have a skill of cooking. So maybe A is representing someone like Gordon Ramsay, who cooks food. And person B is representing someone like Walter White, who also cooks, but he's a different person and it's a different kind of cooking, right? So again, the objects look identical, but they're representing very different kind of cooking and very different people, although similar in some ways too. So if I compare them, JavaScript goes, no, these are two different people. And that's what we get with objects. So to recap, primitives are assigned by value. And those are numbers, strings, booleans, null, and undefined. Objects, on the other hand, get assigned by reference. And those are objects, arrays, functions, date, and regex. So now what? What do I do with this information, right? I want to show you some real world examples where this actually matters. So first one is comparison, where we looked at it. But a lot of times we need to check values against each other. A very common thing to do in any programming language, in pretty much any application. Say your app is a alarm clock app and you want to check the time and see as soon as it hits 7 a.m. you want to sound the alarm. That's a very simple concept, right? 7 is just a number. You might have something like this actually in JavaScript where you check the current time of day, and as long as it matches 7, you can do a triple equals and that's it. You're done. This is basically all you have to do when you compare those two numbers. Versus say, this is something I had to go through recently. So you have a profile page and you want to enable and disable the save button based on whether or not the user has updated the profile, right? So we want it to be disabled at first, but as soon as the user changes anything on their profile, you want to enable the button then and allow them to click on it. If you simply compare the original object, if you compare that object with the object that the form is giving you, they will always be different, because even though they might look alike to you, they are different objects in memory. So comparison will always return false, which means there are always going to be different objects. So your enable or your save button is always going to be enabled. Another scenario that I can think of is when you pass a variable to a function and you want that function to perform an operation on that parameter. Actually, I'm going to show you this in the browser. So say I have a function that says function increment age, right? And I pass in an age to it. And I want the function to take the age equals age plus 1, right? So I want to increment my age. If I simply say const my age equals 10 years old, and I'm going to call the function increment age and pass in my age, what do we think is going to happen? Well, we think that it took yes, there it is. So this my age, we are passing it into this function, and we think that age is going to be age plus 1. So I think my age should now be 11. But if I look at my age, it's still 10. Now, why is that? Well, the value of the age variable is a number, so it's a primitive. So when you pass it to a function, you're actually passing the value of 10, not the variable itself, not the age itself. So it gets copied by value, not reference. Whereas if I have a function that takes, instead of increment age, same thing, but it actually takes an object. So let's say we pass in the entire user, and the user object has a age property on it, user.age plus 1. I know I can do a shorthand, but we're simplifying. If I now have const me equals this object that has age in it, 10, 12, 10. And let's say I do increment age, and I pass in, not user, me, right? What do we think is going to happen? Well, I'm passing this object type, not a primitive and non-primitive. We're passing it to this object, is going to get passed in as reference. So the actual me object itself is going to go in here, and the age of that object, which is the me object, is going to be manipulated. So let's see how that works. Me, now age is 11, right? So again, that's because objects are passed as reference. So when I call increment age and pass in my object, actually passing the reference itself, which, by the way, may or may not be what you want. This is a really important thing. And as a side note, this might seem like a good idea now because we're like, oh, well, we're manipulating the right object. In functional programming, we call this a side effect, right? This is, most of you probably know this, but that means the function affects variables that are outside its own context, meaning this me object, which does not belong in the scope of this function, it gets affected by the function, which is a big no-no in functional programming. The concept of pure functions is that they don't change variables outside the scope of themselves. They create a new variable and return that new variable back to you. But that's a lesson for another day. Water break. Lark. So as you can see, there are real-world consequences to understanding value versus reference, right? And that could be the cause of a lot of your bugs. When you understand how values are set and passed around, you can catch those bugs a lot faster and avoid making mistakes again. So that was comparison. I also want to cover copying. So let's go back to the browser for one last time. To the browser. So whenever you assign a value, const a equals 1, right? So I'm going to do this, and then instead of assigning a number to B, I'm going to assign B to A. Okay, so now we're talking about how the values get copied. So if I'm referencing A and I'm pointing B to A, right? What is A? A is 1 and B is 1, right? If I change A to 8, oops, oh, the const, they can't change. Let A, browser, let A and let B, right? A is 1, B is 1. So if I set A to the number 7, what do you think is going to happen to B? Let's take a look. B stayed as 1, right? But because again, we copied the value. B was not pointing to A, B was pointing to 1. So if I change A, B is not affected. Whereas if I use an object instead and say A's name is Sina, and now I'm gonna point B to A, right? What is A? A Sina, B Sina. Now, what if I change the name of A to Oli, right? A is Oli. What is B? B is also Oli, right? So why is that? Again, because it copies, B is pointing to the reference of the object because it's not a primitive. So, and even more interesting than that is when I assign A to something totally different, name equals Craig, right? So what is A? A is Craig. So would you say B is also Craig? No, B stayed the same because B was not pointing to A. B was pointing to where this Oli object was in memory. It has nothing to do with A. The fact that A changed and that affected B was indirectly, it was affecting each other. They were affecting each other. And that means that if either of them, not just A, would be updated, the other one would also see the change, but this is an entirely different assignment. So it just takes A out of the game and A is not pointing to that original object anymore. Okay, so hopefully that was clear. You have to go play with this stuff and make sure you understand it for yourself. You can come back and watch this again. The second time, it will make a lot more sense, hopefully. I'll promise you, you'll get it. Things like this come up a lot in JavaScript interviews, so this is definitely a good one to know. And with that, my friends, we have reached the end of the series. But wait a minute, what's next? Is this all? Well, I'm glad you asked, Oli. If you followed the series, first of all, I want to say thank you. I hope you found it useful. But this is not where this JavaScript journey ends. Obviously, there's a lot more to learn in JavaScript than the 10 things I taught you. And if you followed the whole playlist, awesome. So here's what I'm going to do next. I'm going to continue with 10 more concepts, but I want them to come from you. I'm going to look for comments on any of the videos in the series, the 10 videos. Leave a comment and tell me what specifically about JavaScript, a JavaScript concept, you want to learn that you've had a hard time understanding. It has to be a fundamental. It can't be some framework or something super niche. That's all I'm asking for, right? You can ask anything else as long as it's a fundamental. I will even mention you by name and send you a beautiful color code sticker like this, no matter where you live in the world, for free, as long as I can ship to your country. All you got to do is suggest what you want to see for episode 11. And now for the big announcement. I've decided to create a full JavaScript course for anyone who is looking to get their first or next JavaScript programming job. I've spent years putting this thing together, and finally, with the help of my team, it's coming to life. It will include JavaScript fundamentals, using the Y method, something I call the Y method. I've used this a lot in this series, so if you like the way I'm teaching these 10 videos, that's the way it's going to be for the full course. Interview preparation, I get this asked a lot. Common mistakes that people make during interviews, and you can easily avoid them. So there's going to be an interview prep section in the course. Mastery mindset, this is something that very few people talk about, something that you can learn and use it to go and learn any other language. It doesn't have to stop with JavaScript. Again, using the Y method. And one of my favorite parts of this is what I call expert conversations, where I've picked some of my friends or some of the more, I guess, famous YouTubers and teachers from Twitter or YouTube or Front-End Masters and Udemy and a few other places. I've decided to talk to them and record those conversations, hours of expert advice on how to nail the language of JavaScript specifically. No matter what your goal is, whether you want to get a job or you want to get a better job, you want to make more money, you want to just simply become the expert in JavaScript, still the world's most popular programming language. Not a bad thing to nail, right? So if you want to know when the course is released, I will be announcing it on this channel, so make sure you subscribe or go to colorcode.io and sign up for early access. There's a form there. I do not send you marketing emails or any bullshit like that. It's simply a way for me to let you know when the course is available. JavaScript Mastery. And with that, again, I want to say thank you for watching the series. It's been a lot of fun for me seeing your reactions, and it's just been such a positive experience on YouTube. YouTube is notorious for having really nasty comments and people fighting. I haven't seen any of that in this series, so that's been truly amazing to see. And this has been 10 things JavaScript developers should know, but probably don't. I'm looking forward to hearing what you want to see for episode 11. Now go write some code, and I'm looking forward to sharing my full course with you very soon. Salut.